Hi and welcome back to my channel. For this project, we are going to be doing a GitOps project. It's going to be an end-to-end deployment of a quiz app built in React.js. I'll be using Github Actions as my CI/CD. I'll be deploying this on Kubernetes and I'll be using ArgoCD for my continuous delivery. So a quick introduction, just some little issues with automation and the problems. Automations are manual. There is always a drift in infrastructure, no history of changes, microservices complexity, there is no versioning of infrastructure changes. So what is GitOps? Before we get into what GitOps is, one of the issues we're trying to solve is who made the changes in the infrastructure, who made changes in the code, who made changes in the deployment, who approved the PR, and when. So we are looking for a timeline, or we are looking for a better way to manage or audit our deployment and know who made what and when it was made. More like we are looking for the timeline and who made all the changes and make our deployment more auditable. So what is GitOps then? So GitOps is a way to, continuously deliver your application. Changes made in Git repo triggers automated deployment. It provides a centralized auditable system for managing our configuration. And finally, it uses Git as a single source of truth for infrastructure and our application configuration. Benefits of GitOps: we have an improved reliability and stability, version control and rollbacks. It enables collaboration and code review. It simplifies our infrastructure and our application management. So the workflow for this project will be: developers will make changes to infrastructure or the application code in Git. Changes are reviewed and approved. GitOps tools detect these changes and triggers automated deployment, and deployment is rolled out to the target environment. So the tools I'll be using for this deployment will be Git, GitHub, Github Actions, Terraform, Docker, Dockerhub, AWS, ArgoCD, Kubernetes, Prometheus and Grafana for my monitoring. You should have a basic understanding of some of those tools. If not, you can read that up, and if you know alternative tool, then it's easier for you to follow. So this is the architecture of our deployment. So first we'll be starting with building the application in your favorite IDE in your local machine, then push this to your GitHub Actions. So with your code, you're going to be writing two pipelines. One will be to deploy your application, and the second pipeline will be to provision a Jumphost that we will be using to manage our Kubernetes cluster, or a Jumphost that we'll be using to manage our infrastructure. So once you have these two pipelines set up, I'll be providing two Git repos for this project. So the first pipeline will be to provision a Jumphost server using Terraform on our pipeline, and the second pipeline will be to deploy our application. So with deploying our application, we want to run a code analysis using Sonarqube. We'll be using Trivy, we'll be using Snyk to run a check on to run vulnerability scanning on our image, on our dependencies, on the libraries, on the module, and also on the code to show us where we have vulnerability in our code as well. More like a full code quality analysis and file system scanning of our deployment. We'll build a Docker image out of our application and push this to Dockerhub. We'll also update our manifest file to have the updated image that we need for the back end and the front end. Then we'll be using ArgoCD to deploy our application to our Kubernetes cluster, and we'll be using Prometheus and Grafana to monitor our application. Also, we'll be adding a load balancer because yes, we want to have a customized DNS for accessing our application. So we'll be using application load balancer to put between our DNS and our application to route traffic to our application. So the first step will be to do SSH Exchange between our GitHub account and our local computer. Then we'll also set up our Github Secrets. So this will help not to reveal credentials or logins, username and password in our pipeline, or also in the logs of the pipeline. So this makes it easier for communication between the pipeline and our GitHub accounts to put the secrets that we need instead of revealing this. One cool thing with GitHub Secrets is once you have your secrets saved, you cannot even retrieve it, you cannot even view it. You can only change it or modify. You can change it, but you can't view what you have saved in there. Then we'll be running a review on our infrastructure as a code pipeline. We'll also be looking at the application pipeline as well. All right, let's jump right into it. Okay, so to start this off, I would have to first set up my environment for SSHing, set up my environment to be able to push pipelines from the local computer to GitHub to run the GitHub Actions. So just making that SSH exchange between my local machine and my GitHub account. So to do this, I will go to terminal. I will do cd home.ssh. So I am in this folder called .ssh. So this is where I can save all the SSH keys that I have. I know I already have some keys on here, but I'm going to create one from scratch and show you how this really works. So I'll do SSH keygen. Enter file name to which to save this key, I'll call it key, and enter, I will just say key 2, doesn't matter. Enter same again, I'll say key, and yes, now I have a key created. I can do ls here to see the list of things that I have. You see the ones that I created here. I can zoom this in a little bit. See the key I created here, the key. So I have a private key and a public key. I'm going to cat this public key, and that is what it looks like. Next, I will have to go to my GitHub account. I'll go to my browser here and go to my account. So from my account, I have to go to settings. From the profile, I go to settings here. And from settings, I can go to SSH and GPG keys. So, but the one we need is the SSH key. So here I have to create a new SSH key. I'll call it a name, will be maybe the same key, give it this name. Then I will paste in the actual key, which is from here. I'll copy everything from on here to here and paste. I'll paste it on here and do add SSH key. Approved. Then I have this created. These are other ones that I have. Back to my terminal, I would have to now type in this command here. Okay, so next I will make a directory. I will cd it to my desktop. And here I will create a folder or make a directory called project. Then I will cd into that project. On here, I want to clone all the code that I need for this project. So first I need is the infrastructure as a code. I will get that here and I will show you what the code looks like or what the folder looks like. I'll do git clone and paste that in here. Okay, that is done. The next will be to get the application code itself. It also has a pipeline for deploying the application. So I will get that, git clone the application code. So here when you do ls, I have the infrastructure as a code. This will be deploying the infrastructure or the resources that we need. and this is the application code that is a quiz app built on React.js. Clean here and do cd into our infrastructure as a code. On here, I'm going to run this command. So this command here, it configures, Git to use a specific SSH key, and this SSH configuration for operations involving our repos. Okay, I'm also going to run the same command in the other repo. So I would cd back and cd into React, then run the same command on here. Now what I'm going to do, because I cloned, let's assume I don't know who built this code. Now I've cloned them, I want to make them mine, so I have to create a repo in GitHub and connect it to this repo. I'll go back a step. Let's start with the infrastructure as a code. So if I go to the infrastructure as a code and do git remote v to no git link to this repo, it will show me on here. But now I want to change it, because I want to make the code mine. I want to make changes. You're free to use this code, make changes. I can go on here to GitHub and create my own repo. So I go here to repo and here create new. Okay, I can call this IAC. There's nothing called IAC here, and I'm going to make a public create. Once I'm done, I go on here. I need to copy the link of this repo, go to code. So I'll copy this and go back to my terminal. I want to replace this to be mine. So I will do git remote set URL origin, then I'll paste the repo that I just created. Enter. Let's run that command again and see. You see, it's now changed. This is the original that it came with. Now I've changed it. I've made it my own code. So if I make any changes and I push, it goes to this repo and not to the authors repo. Once I make a push, it comes to my code. So I can use this and make any changes and make it mine. Okay, I can do the same for the application code. I will go on here and create the second repo, new, and I'll call it React.js, and I will make it public as well and create. I will copy this link back to my terminal. I will cd back, then cd to React.js, and I'll run git remote -v to see what it is. Then I will run that git remote set URL origin, then I'll paste this. Let's run that command again. This is the original and this is the one we have created now. Okay, so we've set up our repo. They are now mine, right? So whatever change I make on the repo, I can push it to my own repo, not to the original author's repo. Next you have to do will be to run git config. If you don't already have that set up in your local machine, will be to do cd into any of the code and do git config. I'm sure you must have done this before you're able to use git command and change repos. But just to also show this, global username, then you type in your username. It's my git username, and I'll also do the same thing. Oh, let me scroll up here and do user email, and I will type the email of my GitHub account and set that. Okay, This is actually global or local in your machine. So once you have it set up, you don't have to do it in every repo. I'm sure you can do this even from the root directory of our project. So I can do cd space and run this command, and it's already registered. So you can run it from anywhere. It just registers your username and your email in your local machine, so it's global in your machine. Okay, next we'll be going to our AWS to create resources. So the first thing we are going to be creating on AWS will be to create IAM that will have the permissions to do some of our AWS stuff. AWS and sign in. Go to AWS IAM and you go to users and create a user. Here you're going to call your user app user. I'm going to delete this when I'm done, and I'll go to next. I'm just going to add a policy directly, and I'm giving the person administrator access. So it means they can do anything, like they can do anything with this account. But remember one thing with giving permission, they have to give the least privilege. Just give the person the permission, just the particular permission that they need. If you just want the person to provision EC2s, you just give them EC2s permission. If you want them to provision, VPCs or subnets or whatever, just give them the least privilege. But in this case, administrator access, that's what I'm giving for this demo. I'll do next and I'll create the user. So once this user is created, I go to this user and I'll go to security credentials. From security credentials, now I want to create an access key. I want to give the person CLI access, and I'll accept and I'll do next. This is not necessary. I'll do create access. So now I have created access keys. It's on here. I want to have these access keys in my GitHub and also locally, so I can run AWS commands, and I can also run GitHub access, or I can run GitHub commands to my AWS. Okay, I will have to save this down, or I go on here to GitHub to each of these repos that I've created. So I am in this repo. I have to go to settings. So this is the app repo. Go to settings, go to secrets, go to actions. I don't have any secret here, but I'll be creating a lot of secrets for this application. So the first secret that we need is called AWS Access Key ID. I go on here, that is the ID. I copy this and paste it on here and save. Then I'll add another new one and copy this back on here, paste it, and I'll call it AWS secret access access key, and I will save. Next will be to go to the other repo, which is this one, and do the same thing. So go to settings, AWS secrets access key. AWS access key ID. One thing is, once you save this on here, you can never view it anymore from here. Still have it on here. I can save it somewhere on my local in case if I need to use it again. or I can download the CSV. Yeah, this is what I'll do. I'll download the CSV. So now it's in my computer. I can use it to set up. I'm done with this. Once I am done with this demo, I am going to delete this key. Okay, or delete this user. Next will be to also copy let me open these two repos so I can be adding the keys simultaneously. I have the IAC and go to repos. What I need is now this one. I'll go on here to secrets. Another thing that I need is my S3 bucket. I will go to S3. Okay, so once I'm in my S3 bucket, I will do create bucket. I'll give it a name and every other thing as default, and I'll create bucket. This bucket name, I will go to here and add it. And I'll call it bucket underscore TF. I'll show you in a minute why I added that. Okay, so I need to set up Terraform and AWS CLI locally. I know I've done this on my local machine, but I'll just show you how to do this. I will share a repo that has the processes, like documentation of everything I did for this app or that I did for this project, for you to copy the same and use it. So it will be in the repo, no, it will be in the README of the repos I clone for this demo. Or it will also be in a publication. I'll put the link in the description of this video so you can see all the commands that I ran to set up the commands in my machine. With that being said, you can set up Terraform using Brew if you're using Mac OS. So I used Brew to install Terraform and AWS CLI. Okay, you can do AWS config and it will ask you for the steps. Once you have AWS installed in your local machine, you can do this. But I already have it set up. So now it's showing me my access key. But if I have a new access key, at this point, this is where you put the access key and do enter. It will ask you for your secret access. Since I already have one here, I don't have to put a new one, but you can paste in a new one in here. And for instance, if I'm putting this as my access secret, you can put it and do enter, but I don't have anything I'm putting, so I will still use the one that is already set up. Enter, it's asking for region. I already have region, but if you have a new region or if you have a different region, you can put it in here and do enter. And output format, people use JSON. You can also leave it blank. It doesn't really matter here, and you're all set up. So this is how it works. Once you have your AWS CLI installed in your local machine and you want to run commands from here to your AWS. So creating the S3 buckets, we can also do it locally using the CLI, or you can go to the console to create that. We can go now to our IAC and I want to cd here, or I want to go in to this. I can do code this because I want to use Visual Studio Code. So it's going to open for that folder, and let's see what we have on here. Okay, before we go to the pipeline for this IAC, I want to review what we have in our Terraform. Okay, I will start from the VPCs. For you to understand, you can go to Terraform and look for the module. But just a quick rundown, the resources we're having here is the VPC. We have the internet gateway. We are, provisioning subnets, route table association. We are doing security group. For ingress, this is what we want to allow into this jump host. And this, for outgoing, yeah, we have, nothing for egress. So variables, these are like things that I use for. So what I'm setting up is actually a jump host. This jump host is just the regular EC2 server that we want to run our Kubernetes from. We don't want to provision a machine and be in that, or provision a cluster and be inside the same cluster to run commands. So we need a jump host. Then from that jump host, we can create our EKS, create our cluster, then run commands from that jump host. So if you need to do anything, you be on that, SSH into that jump host and run your commands. So this jump host, we have the AMI is in this variable. I have to, if you go on here, is down here. You can look for this ID, go to AWS console to look for this ID. I can show you how to do that. If you are AWS, you go to EC2. Once you go to EC2, you go like you're creating one EC2. You pick Ubuntu or whatever server whatever machine you want. You will see this AMI. This is just the code that you need for every machine. You copy that. That is what I have on here for the machine that I want. So you can replace that with the one you want, or you can go with the same AMI. So back to the jump host. Next is the instance type. For instance type, I also have that in my variable. I want T2 large. You can have T2 micro, it can be nano, it can be medium, but you have to know the capacity of the machine and the capacity of the tools you'll be using on it. That will determine the size of your instance. Okay, back to the jump host. The subnet ID, VPC, the instance profile, the volume size, template. So this install tools.sh are the tools I want installed in my jump host once I have this provisioned. I'm also going to create a role and a policy for this user. So for this Ubuntu user or for this Ubuntu machine. So this role, all the things I want to allow, and the policy, I'm giving it administrator access. This is not recommended, but you can use the principle of this privilege to give the user the role, the access that they need to run all the commands. For Terraform here, okay, we have to specify the the provider we're using, which is AWS, and we also have to talk about the backend, which is going to save the Terraform state file. Here we have a bucket, and remember to change the bucket name. I've created a bucket called this. That's why I still retain this name. And know that this is the region where I'm provisioning this. You can also change this region. That will be all for this. Next will be the pipeline that is going to deploy this. Let's look at the pipeline. First, I give it a name. It doesn't matter. You can give it any name you want. And this pipeline is going to run when there is a push to the master branch, and also when there is a change in this Terraform folder, or when there is a pull request, the same thing, what is either a push or when there is a pull request for masters, and in this if there is a request or change request in this Terraform folder. And here I have to set up my environment, which would be the AWS access key. I have this defined already here. let's be sure it's the same name. We have access key ID. I have access key ID and access secret access key. Secret access key. Be sure that is the same name for it to allow us to run. Here we have the bucket TF state. So remember I called it TF. If you go back here, I called it TF. Let's see if I can edit this. I cannot edit it, so we'll just go back and use the same name, TF. I can leave this, but change what I have on here. I have to define the variables for this pipeline, the AWS region. Now I'll have to define the jobs. We are running a Terraform job. First, we are using Ubuntu latest. Our working directory is this Terraform. It's inside this Terraform that is deploying all the Jumphost and all the things that we need inside it. So first, it will do a checkout source code, set up Terraform in the pipeline, in the GitHub action. It will run a Terraform init, it will run format, it will run validate, it will run plan, it will look at the plan status, then it will apply. This apply is going to apply to provision everything that we have in this Terraform. Okay, here I'll have to open my terminal and let's just do initial push to git status. Okay, there is some change here. Yes, because I changed the bucket name here. All these are not even because I didn't even use them. Okay, yeah, I used the bucket, so this is going to use the bucket on here. So yeah, they are necessary. I think it's only the bucket that is necessary for this step. So our environments, we don't even need all these ones for now, but let's just leave it there and do git commit and do initial commit, git push. Okay, so back to our code, and yeah, is on here, is pushed, so is our master. And let's go to action, and nothing is in the action. Why? Because we didn't make any change on this Terraform. We have to make a change in this Terraform for this Terraform folder for it to have a change. So I will go to maybe any of the files and add, oh, I have hash here, so I can remove this hash. So there is a change now in our file. So let's see git status. Okay, git commit updated, oh no, updated Terraform, then git push. Once there is a push, we go back here and refresh. Yeah, now we have something running. So it will set up the job. Next, it will check out the source code. While this is setting up, oh, let's just give it time. Once it's done, we can go to AWS to see everything that it has provisioned. Not everything, it's just the Jumphost, the EC2. Okay, give this a couple of minutes. Okay, it's applying the job. We'll refresh here. Okay, it's complete. So let's go to, we can also look at our output for apply for the things that we requested for output. So the Jumphost IP and the region. So this is the IP 235. we'll go here and go to our EC2 and look for our running instance. Now we have this, click on it, you see 235, and that is what we have on here, 235. We need this to, we need to connect here. You can go on here and you have this. One thing I didn't mention is this key pair. I've already created this key pair before. Is local in my computer. I use the same key pair for building my infrastructure. So if you come on here, key, this is the name I give this key, and I specify that key when I'm writing my Jumphost. So this is the key that I need. So that's the same key I'm going to use to SSH, and it's simple to create a key. If you want, go to here, you have key pair, you create key pair, this, give it a name, key pair, you create, you download it, and you use the same name on here in your variables. You put the key name here and you can use that to the port. So that's the key I'm going to use to SSH into my EC2. Go in here and I'll do connect, and you see this and you see this code, you copy it, that's all you need. And before you SSH, be sure you have that key where you're SSHing into. Okay, I think I have it in my downloads. I can open a new tab here. CD home, LSCD, downloads. I have that key here, so I can run my SSH from here. And it asks me this, yes, and now I am in my Jumphost. I'll clear this. Okay, being in the Jumphost, what next do I need to do? My Jumphost. I'm not really sure I have all this, with the time, I'm not sure I have all this installed in my Jumphost. So I'm going to have all that installed in my Jumphost. Just make sure all these tools are in there in my Jumphost. To run AWS command, kubectl, EKS CTL, I will have that configured. I'll go back on here. Okay, I can move this to another screen. And here we have Docker. Let's confirm if we have Terraform. We have Terraform, and let me try kubectl version. Okay, I think we have that. Let's try AWS. Okay, we have that. Okay, we do. These are all the tools that I have mentioned in my Terraform to install in the Jumphost. So I'm just confirming that they are present. If not, I can install them manually. Let's check for this. Okay, I think we are all set. So next thing will be to create an EKS cluster. This is going to take maybe 15 to 20 minutes, depending on the size or the number of clusters and the things you're creating. So here we are asking for EKS CTL to create a cluster and give it a name. This is the name we are giving it. The quiz app and the region, we write the region. The node type is T2 large. we specify the minimum and we specify the maximum. This is the type we are going for. If you want different types, yeah, you can specify for different types. You can put your minimum, your maximum, or whatever you want. So I'm going to go with a minimum of 2 and a maximum of 4. Yeah, our cluster is created. So back on the application code, I'll cd back and cd into our application, and on here I can do code to open it on VS Code. Here in the application code, a little walkthrough. This is the back end, and let's look into the index.js. This is what it looks like. Okay, so if you're going to use this, one thing that you will have to do will be to create a MongoDB database or Mongo database and have your data in there. Use the string to connect. And this is what the Docker file looks like. This is for the back end. For the front end, React.js, our code is in here, and I'm connecting. This will be my back end endpoint. Because I have a DNS created, that's why I'm setting this to be my back end endpoint. So you can create something similar to this. Or if you're going to use the application or the code the way it is, you have to change the API URL for your back end. That will be it. If you're going to try it locally, you can use this, provided the port for your back end is 3000. The Docker file for the front end, this is what that looks like. From node, the working directories app, I am copying the package.js. I'm installing all the packages. Then I'm doing npm run build. Then I'm doing a start to start the application. I think that's all you need to know about the front end and the back end. And the next here is the Kubernetes file where I'm deploying for the front end. No, this for the front end. And for the front end, I am also defining this, my environmental variable, and I'm connecting this to the backend API or my backend endpoint. I also set up my secrets using the Mongo URI, so I have to convert this to, encode it to base 64 and put it on here. So if you have a connection string for your MongoDB, you can encode it, and that's what your backend is going to use to connect to your MongoDB, which is this connection here. I have all the deployment and the service in one file. For the database, I have the deployment and the service. I also have the PVC, the volume claim. I have the PVC, and I also have the service all in one file. Then the front end, I have the deployment on here, and I also have the service on here. I have ingress. So for the ingress, yes, I have to define the host for my application. Once we finish with this, I will use the ingress. Since I'm using load balancer, I will use the load balancer DNS and do a record and add this as my a record to route it to the load balancer. Then there's the secret file. Now I'll get to the CI/CD or the pipeline to deploy our application. Let's also. So with this, once there is a push on the master or there is a pull on the master, is going to trigger this pipeline to run. And the jobs is first going to create is first going to set up the environment using Ubuntu latest. So I'm going to do first front end test. I'm also going to do a back end test, do a security for the front end and the back end, and also build the image and push to Dockerhub. Same thing I'm going to also do for both the back end and the front end. So for the front end test, I'm going to use, of course, Node. I'm going to install all the dependencies, run a lint, run a prettier, all this to look at the format of the code. I'm going to run a test, then run a build, and doing a build on the front end. Once that is done, I'm going to set up Sonar Scanner. I'm going to set up, I will have to go to Sonar Cloud, sonarcloud.io. Come in here, you log in. I'm using my GitHub account to log in. So once you're logged in on Sonar Cloud, you go to create a new organization. You create that manually, give it a name. Here I give it Quiz App. And make sure your key is the same name so you remember that when you're setting up your secret. Analyze a new project. Display name will be the same thing. Quiz App. Project key, same thing. This is going to be public, and next. I'll select on previous version and create project. Once this is created, I will go to GitOps and add some secret. So first will be to remember we have organization, we have project key, and we named it the same thing, which is quiz app. Go back to our code here. Go back to the code. See all the names that we need to create secrets for in our GitHub repo. Here we have the Sonar token. We are going to create that as well. And we have Sonar organization, we have Sonar project key, and we have the Sonar URL. Organization saved. Add a new secret. This will be the Sonar project key. I'll paste it here, making sure it's the same name, quiz app. Remember, this is already created here, is the same name that we used. So just confirm. Add secret. I'll create. Next is Sonar URL. I'll paste that here. Sonar URL. I'll copy that. Paste on here. Then go to Sonar Cloud and copy the URL of Sonar Cloud. So it's sonarcloud.io. I'll paste that on here and add secret. Next will be to create the Sonar token. Go to security, create a new token here. I'll give it a name. App generate token. I'll copy that token and use it and create a secret on the GitHub account. I'll paste the token here, then go back to the code and make sure I copy the same name. So add token. Add secret. Now these are all the secrets that we have for this repo. Here I'm going to create a personal access token for our GitHub, go to developer setting, go to personal access tokens. I'll create one here. I'll delete this once I'm done. I'll give it a name and I'll give it all the access that I needed to have. I'm just going to select everything. But remember, if you're creating this person access token for someone in the organization or to give them access to do something, you have to use the principle of least privilege. Give them just the access that they need. But for here, everything. Generate token. Here's the token. I'll copy that and I'll go back to our secret. New repo secrets. I'll paste that on here and I'll call it GitHub token. Here it's called GitHub token. GitHub token. I'll copy that. I'll paste the name here. Add secret. Oh, failed to add secret. Okay, name starts with GitHub. Okay, we have to change that again. Paste. No. Now put copy that and paste and add secret, and that worked. Okay, so back to our application code. Now we've created GitHub token. Remember to change the name and update it to what you used. And what else is left? Yep, we've added all the secrets that we need for our GitOps action or for the pipeline. So next we need to create Snyk. Cool. And once you're in, sign in. I use my GitHub connected to my Snyk. Go on here, settings. Yeah, I'll copy this organization ID as my token. I'll copy this as my token, organization ID. Go back to GitHub, add a new secret, paste that. I'll call it my Snyk token. Go back here, copy that, be sure it's the same name. Go back to GitHub and paste that. Add secret. Now check again to be sure everything looks good. Next we need Docker username and Docker token or password. So go here and go to Dockerhub. You sign in, or you can sign up if you haven't. I'll sign in here. I'll create a token, go to my account, my profile. Oh no. Go to my profile here. Go to my account, go to security, then create new access token. I'll give it a name, app, and generate. And I'll copy this token. That will be my Docker password. Back to GitHub account, use repo secret, paste that, go here, copy Docker password. I'll paste that here and add secret. Create new one. This will be the Docker username. I'll paste that here and my username go here. That's my username. I'll copy that. I'll paste it here. Add secret. Any other thing? Nothing else. So let's walk through this repo. Let's walk through the pipeline, look at the jobs. So for the test, we're going to first do or install our dependencies, do the Sonar scanner. Here, look at the back end. This is the root directory, and next will be the front end security. I'll do the Snyk. I'll use Snyk to scan through our code and do a code test. Next will be the back end secret. Do the same thing, and the front end image is to create an image using our Docker file that is in the directory called quiz app. Once it builds this image, it's going to push this to our Docker Hub. And I added this password stdin, so my password or my credentials doesn't show in my log in case if the log gets into the wrong hand. And I'll close this other thing. So back here, then I will run Trivy on our Docker image to make sure there is no vulnerability in the image. I'll also use the Snyk CLI authenticate to also monitor our container for any vulnerability. I'll do the same thing. So this is for the front end. I'll go back on here. This is for the front end. I'll do the same for the back end image, and I'll show it the working directory for the back end, which is the back end folder. And it's the same thing. It's going to use the Docker file that is in the root of our backend folder. And finally, I'm going to run a scan on the manifest file using Snyk to run through the manifest file. There is a GitHub Actions for that. I will run that. If you need more, actions to run, you can go to GitHub Marketplace and look for actions and add to your pipeline. Now I'll go here. I want to commit this code. I'll look at the status. And I'm going to do git commit. Now type a message, initial commit. Enter, then git push, enter. So to push this code, I will go to GitHub Actions. Now there is a build going on. You see the structure, the test for the front end and the back end, the security for front end and back end. Then we have the back end and front end image. That is the structure of our pipeline. I'll go on here. You see after the test is the front end test. Then we have the back end test. We have the back end test. Then the front end security will have to depend. We'll need the front end test to finish, and the back end security needs the back end test. Front end image needs the front end security, and the back end image needs the back end security. Then the manifest file, it just needs the back end security and the front end security to run that. Yep, that's the structure, and that is how it is on here in the architecture of the pipeline. You can click on the pipeline and see what is going on, and go through this. Is a lot of logs to look at. So for the testing, oh, this is really big because it's going to Sonar Cloud. It's going to run our code quality analysis on all our code. Yeah, let's check this. Oh, the test is done for back end and same with front end. So now you see the security is running for the front end and the back end as well. So this is where the sec comes here. That is the DevSecOps. This is where the security of dev comes. So you see the result of our code quality analysis. To see more on this, you can go to SonarCloud.io. Since you have a project created, you can go there to look at the result of all your scan. For Snyk as well, you're going to go to their website and see the result of your scan. I'll refresh here. Oh, something failed. Go here. Oh, Snyk CLI authentication. Oh, something is wrong with our authentication. Okay, I guess, yeah, I didn't copy the token. What I copied is organization ID. Okay, I'll go back here and dashboard. I'll go to my account here, profile, go to account settings, and from there, yeah, I see the token here. Click to show. So it's in the general, click to show, and I will copy that, and go back to my GitHub. Yeah, I'll go to the settings of the repo, add secrets. It's just going to edit the secrets that I have. No. Okay, go to secret actions, look for Snyk token, edit, and I'll edit the value. I'll paste that and update. I'll go back to my actions now. Yeah, I'll go back to actions, and I'm going to rerun the jobs, rerun all jobs. Yeah, I'll rerun all jobs. So to start out this job from the beginning again. Give it a couple of minutes to run. I'm actually gonna fast forward this. I'll refresh here. Okay, our test is done. Now we're waiting for the security both for the front end and the back end. Refresh. Okay, the front end security is done. It means, yeah, the token is working. Yeah, the back end security is also done. Yeah, we look at the code test. You see there are some warning here. You can also implement that back in your code. So these are things that you have to check as a DevOps engineer or DevSecOps and inform the software engineer or the developer to like improve their code. Yeah, I built the code, but it's just something basic, so I don't need all the hardening. But I'll go back and work on the security issues or all the concerns that I see from my CI/CD pipeline and improve the code. I know there is a lot of things to improve on that application. You can also review the backend security. Now we have the front end image. Okay, now we're done. It has pushed the image to Dockerhub. Here is running Trivy on the vulnerability scanner. So it's scanning the image. So the image comes in with dependencies. It comes with, you know, libraries or let's say modules that are all in the package.json file. So it's going to scan through all those because some of them came from the internet, and it's just going to scan every component of our image and be sure that it doesn't break, it doesn't create a loophole for our application to break or vulnerability in our application in general. I'll refresh here again. Yeah, it's still running. Scan. Yeah, I'll refresh again now. Okay, is running the container monitor. All right, let's go back to our Jumphost. Okay, look. Yeah, our cluster is up and ready. I'll run this to update the config for the cluster name. I'll leave all this command in the readme.md file. Yeah, we check for our node. Here we have two nodes that we specified, minimum of two. Then we are going to download for load balancer. Next, we are going to create a policy. We'll use this command to clear this. Next, I'll be doing these utils to create this OIDC provider and add this, and I'll specify my cluster name. Next, I'm going to create the IAM service account for this cluster, and I'll use this command. Make sure you change the account ID, the AWS account ID, because if you run with the same code, it might not work because you didn't change your AWS ID. I'll give it a couple of minutes. So you see on the command where you see AWS IAM, you see some numbers before policy. That's my account ID. So remove that and add yours. Here I'm going to install Helm. I'll be adding some packages using Helm. Here I'm going to add a repo called EKS. Yeah, I'll update my Helm. Update all the repo. First, I'm installing the AWS load balancer controller for the same cluster name. Well, that is done. Once you do this, you give it like 2-3 minutes before you go confirm this on the AWS console. It takes a couple of minutes to get provisioned, so give it a couple of minutes before you check that out. Or if you check it out, it doesn't exist, just give it a couple of minutes to be created. Okay, back here, refresh all, everything passed. So take your time to review the results. Take your time to review the logs from the scan. So back to our Jumphost. Here I will check for the load balancer. Yeah, the load balancer controller is here. I can also go confirm that. kubectl, create namespace. My namespace is quiz. I'm going to call this quiz, and be sure you have the same namespace in your manifest file, or if you don't, it's actually going to create it. I'll get all the namespace I have. I have quiz namespace. The rest are default, comes with a cluster. In my manifest file here, you look back and look at the namespace. That's what I have for quiz, and that's what I have for all the deployments, the services, persistent volume claim, the secrets. I all have them all in one namespace. Here I'll create another namespace for ArgoCD. Here I want to now install ArgoCD. Using this command, yeah, I'll run that. Remember, all the command is going to be in the readme file. I'm going to attach that in the video or in the description. That is done. Yeah, I'll get all the pods. Okay, pod initializing. Some are just starting. I will give it a couple of seconds. Run it again. Okay, they are all up and running. I'll run this command here to patch this ArgoCD to our load balancer. So you go to AWS, I will go here and search for load balancer. EC2, go to load balancer. It's down here. Click on that. See, my load balancer is up here. Refresh. Yep. So back on here. So JQ is a dependency to extract our ArgoCD password. Here we're going to get the ArgoCD password. This is what I'm going to use to sign in as the admin into my ArgoCD. So I'm going to use this DNS, copy that, paste it on my browser, enter. You're going to see this, just show more details. Yeah, go view the, or just visit the website. Yeah, visit, allow, and now type in admin and use the password that showed in our terminal to connect. So I'll copy this and I'll paste it on here and sign in. Oh, no need. Now I am in ArgoCD. So this is what ArgoCD UI looks like. Next, I'll be adding Prometheus. Now also add Grafana using Helm. They are all added now. Here I will do repo update. Here I will install Prometheus and I will create another namespace for Prometheus and Grafana called monitoring. It will take a couple of seconds to install. Okay, that is done. Next will be to install Grafana. I'll use this command to install Grafana. Yep, our Grafana is installed. Now that our Grafana and Prometheus is ready, I'm going to change the cluster. Instead of it having cluster IP, I want to change that to load balancer. Here I will get the service. Clear this. I'll edit Prometheus. Here I will type colon SE space NU to number the lines. So I'm going to line 49. Oh, 48. Change this from type cluster IP to load balancer. Save. I'll do the same for Grafana. And I'll do the same thing, colon SE space NU to number the lines. I'm going down to 39. So I'm changing the type from cluster IP to load balancer. So I'm able to use the load balancer DNS to connect to Grafana and also to connect to Prometheus. Now I can view the service in my monitoring namespace. Here I will refresh load balancer. I see here, but I don't even know the one that is for Grafana and the one that is for Prometheus. Here I'll view the service again for monitoring namespace. Here I see the namespace. So for Grafana is 8399. Okay, I see the one for Grafana and the other one will now be Prometheus. So the Prometheus is AF13. Okay, back on here, AF13. Copy that, go to my browser, paste that, put colon 9090. That's the port for Prometheus. Yeah, everything looks good. Here I'm going to get the password for our Grafana. Yeah, that's the password for Grafana. I'll get the DNS, load balancer DNS for Grafana. Okay, copy that. Go to my browser. I'll paste that in here. Enter. I'm going to use admin to sign in and the password that shows in the terminal. Here, I'll copy this password and I'll paste it on here. Log in. No need. Data source. Prometheus is our data source. Here is to paste the server URL. I will go here to Prometheus and copy everything from to the end of the port. I'll copy that, paste it on here. So if it checks out good, if it's like this, that means it's good. You save it. But if it's red, that means you're not copying the DNS well. Come back to home. We are going to dashboard to set up dashboard. We'll create new, import. I'm going to use this simple ID for dashboard, which is 6417. 6417 is a simple Kubernetes dashboard. Data source is Prometheus, import. And here you see our deployment replicas and everything that we have deployed so far. We've not deployed our application. So this comes from the monitoring namespace, come from ArgoCD namespace. This is what we have in our cluster. Right now, we don't have anything from our application yet. Okay, go back to our ArgoCD. And here we'll be adding our manifest file. I'll copy the Git repo here. Application name, I'm going to give this quiz. Project name, default, I'm going to set the sync as automatic. And the source, I'll paste the GitHub repo here. The GitHub repo that has the Kubernetes manifest files. So the path here is Kubernetes dash manifest. Go back to the application code. See that in the manifest file, in the manifest folder, Kubernetes manifest, that's where we have our deployment files. Okay, I'll save that. Namespace is quiz. Remember, we created a namespace and we have that in our manifest file as well. So create, and you allow this to do its magic. So it's going to sync, it's going to provision everything that we have on here, deploy them in our cluster. It's going to take a couple of minutes to do this. Just be patient with it. If everything is not working yet, just give it time to sync, provision all the resources, and you can go back to your Jumphost and look at the logs of your backend, front end, the MongoDB, that's the database, and be sure you're getting good logs. Yeah, everything looks good here. It's all synced and looks healthy. So I will go into this application that we deployed and look at the structure. Click on the deployment to look at the architecture. So this is what it looks like. So this is the application that we created and this is the structure. Let me reduce this. Okay, so everything can be shown in one screen. So we have the Mongo PV, we have the persistent volume claim, we have the secret, we have the backend service. Okay, go back to load balancer, then go to route 53. Want to create the A record for our DNS. And I'll create a new one. The subdomain is quiz app. And it's going to be A record. And I'll turn this on. Is alias application to classic load balancer. Choose region. This is the region I'm using. I'll paste the load balancer on here. And I would save. I'll give it a couple of seconds. Okay, this is synced, or this is in sync with our DNS. Okay, here I'll go to the browser again. Here I'll go to my terminal to check my ports in the namespace quiz. Get port -n quiz. Enter. All my ports are running, and you know this were all deployed by ArgoCD. I will log each of the ports and see. Put the namespace dash. Okay, quiz API is listening on this port. I'm connected to MongoDB, means it's good. So next I will check the logs for the front end. kubectl logs, copy the front end and paste it on here. -n. Okay, and enter. Front end is good. It's running. kubectl. Let me get the ports again. I need to log the database. Okay, this response looks like what it should be for a functioning database. Okay, I'll go back to ArgoCD and look here, click on this. Everything is good. Look at the parameters, the manifest, the events, everything we've done so far on ArgoCD. You can see the events on here. I can close that. Click here again. Whoa, okay, our quiz app is up. So you're required to put your name and an email. I'll put an email, ogo@email.com. Start quiz. Okay, I just answer random and I'll fast forward this. It's actually 50 questions. So, yep. Okay, once you're done, you can reset and start again. Okay, there is a lot of things that I still need to do on this app, which will be, there are just so many components I want to add to it. You can use this and do with it whatever you please. You can change the background, change the container, change whatever you want to change. Make it yours. Use it anywhere, use it anyhow you want to use it. Modify whatever you want to modify. You can change the questions and everything. All right, everything is working good. Let's go to our monitoring, our dashboard to look at more things. Okay, back to our dashboard. You remember the dashboard ID we use is 6417. I'm going to be adding more dashboard here using other codes for you to like look at more things that you can look on your dashboard. Okay, I'll add another dashboard 15757 load. So this is going to be a global views of our Kubernetes. Select our data source. Okay, this is what it looks like. You see, I can change the time to 3 hours. That's really short. It's been up for just 2 hours or even an hour. Yeah, let's leave that for an hour and look at all the things that we can see about our Kubernetes. So we can see the global CPU usage, dashboard. I can go back again and add more dashboards. Okay, I will put another code, which is 1515. I'll change this here to 760. This is going to be the pods, and our data source is Prometheus, and these are the things that we can view about our pods. This doesn't look as pretty as the global for Kubernetes. Go back to dashboard again. I'll add another dashboard, import, put the code 1515759 load. This will be for our nodes. Import our Prometheus, import, and this is what nodes look like. It shows you the number of pods you have in the node, how many hours it's been on. You see the system, you see the network, you see the TCP. You can see a lot of things on here about your Kubernetes, your pod, your nodes. Yeah, cool. Go back to dashboard again, and I'll import another one. Import, put this code 15756 or 758. This will be for namespace. I'll load this, and this is what it looks like. Okay, it's showing you for namespace, for all the namespaces. The overview you can change to the quiz app to view just for the quiz app. You see the CPU usage, you see the RAM usage in percentage, and look at more things. You can go to ArgoCD and uncheck quiz and look, see how much RAM and CPU is using. So with all this number, you can set your threshold for alerting. If you're into site reliability engineering, if you're into monitoring of the application, you can use this threshold to set up for auto scaling or to alert for either horizontal pod scaling and all that. Here you can go back to the dashboard again, and you can load that for the global view again. Tap that in global view, you click on it, and the dashboard will come on. You look on here, look at the cluster, the namespaces we have 3 and 4 default, the monitoring, ArgoCD, and quiz, then the rest are default namespaces. The running pods that we have in our whole cluster, you see the resource, the cluster CPU utilization for the last 1 hour. You see the cluster memory utilization. See each for each namespace, memory utilization by namespace. Oh, monitoring has, because it has a lot of logs that is looking at, maybe that's why the memory is that high. Look at the CPU by instance, look at the Kubernetes pod. Here you see the network, the global network utilization by device. Okay, back to dashboard. Okay, go to the nodes. Yep, I think this has some data to look at. So here you see the list of all the pods that are in our deployment. And it's been up for 2 hours. That's the node itself has been up for 2 hours. That's what the system looks like. There are more dashboards you can look at. Let's look at the API server for Kubernetes. That's 1575761. And that's the API server. I'll load that in. And okay, see the API server health status. And see the HTTP request by code. And depending on what you're looking for or what interests you the most, you can have a dashboard for that. Okay, back to ArgoCD. Everything looks good. Our application is running. Remember, once you have this deployed on ArgoCD, give it a couple of minutes before the application itself will load. Let's look at the back end. Here we'll type /API/questions. Oh no, that's wrong. Questions. Enter. Okay, these are the questions from the back end. Okay, I will copy this and view it on Google Chrome because I'm able to add a JSON viewer extension on Google Chrome, so you can have a better view of all the backend API. I'll bring my Google Chrome here, copy this link, paste it on here, enter. See the way it looks. I'm going to add the extension JSON viewer. JSON viewer extension, the first one. I'll add that to Chrome, add extension, then I'll pin this. Go to my extension here and I'll pin it. Okay, I'll go back to my backend. I'll refresh this. You see, you have a better view or a better representation of our API. So this is the quiz data from 1 to 50, and also it shows the answer here as well. Okay, so this is the structure of our backend. Everything looks good. So next will be to clean up everything we have created, and make sure you clean out everything on your AWS. If not, all these resources are going to be consuming. Bill is going to pile up if you leave the resources on there. So make sure you clean up and go back and check on the console that everything is actually deleted. First we'll start with delete the cluster. So the cluster is going to delete the application and everything in the cluster, which is the ArgoCD Prometheus Grafana is going to clean out all that. Okay, the cluster is now deleted. It will probably take close to 15 minutes, so 15-20 minutes. as long as it took the cluster to create, that's how long it's going to take to destroy, or close to that time that it took to create it. That's how long it's going to take to delete it. Okay, I'll go to AWS to confirm that everything is deleted. Refresh, you see all the load balancers are gone. Back to EC2, see the nodes or the cluster is terminated. So what is left is the Jumphost, which we are going to use Terraform to destroy because we used Terraform to create this. Okay, we're going to bring that infrastructure as a code, and we are going to cd into Terraform because we're destroying this locally. But before you are able to destroy this locally, make sure you have Terraform set up locally in your computer. So initiate, this is the backend config, and this is my bucket name. Once you run this, it's going to create this .terraform folder and terraform.log. And here I'm going to do Terraform destroy. Clear this, Terraform destroy. You can enter on this and wait for it to show you the plan for destroy, and you put yes, or you can do auto approve and it will approve and delete everything. This is not going to take long. It's going to be as quick as it took to create the infrastructure. So just give this a couple of seconds, I would say, maybe a minute maximum. It will destroy everything that it created: the VPCs, the subnets, the internet gateway, the route table association. It's going to delete all that. "30 seconds gone." Okay, everything is gone. So 10 resources were created and 10 destroyed. So I'll go back here and refresh. Here, go to policy. Yeah, I need to delete this policy because it was created when you run. This will just remain. If you don't delete it and you try to create again, you might have issues because this policy is on here already. So I'll delete this load balancer policy. And that's all. User, yes, I'm going to delete this app user that I created. Yes, because it's already exposed. I've shown you guys what is in it. So yeah, I need to delete that. And that's gone. Yeah, next I'll go to GitHub and delete this person access token. This is gone. Go to Snyk and because it's already exposed, I will revoke and regenerate. Revoke and regenerate. Okay, so this is gone. I'm not going to click on show again. So if you click on here and show, it will show the one you're using. You can revoke and create a new one. So I've deleted that. Next would be to go to my Dockerhub and delete that token as well. go here to my account, go to security, and this is the one I just created. It's exposed, so I'll delete it. Okay, and on here I wanted to be sure everything that I created. I've deleted the AWS, I've deleted the Docker, I've regenerated this. I'll have to delete Sonar, and I've deleted this. Next will be to go to Sonar. Go to Sonar, yeah, that is it, which is the app I can revoke this token, so it's gone forever. All right, I think that's all. I've cleaned out everything good. I can go back to my AWS resources and look at EC2, and nothing is on here. Go to load balancer, and that's one good thing with using Terraform to create resources, because once you do Terraform destroy, it will destroy everything that it has created, even though you can still go back manually to look at if everything have deleted. But apart from that, it's really cool because it deletes everything that it created. Right. All right, thank you so much for watching this. Thank you so much for following through. Please feel free to ask any question. If you encounter any issue with this project, feel free to ask your question. Drop your comments. You can send me an email. You can reach out. Then we'll work on this issue together. Thank you for watching, and I'll see you next time. Bye.